Yeah, my name is Mike Wells, and my job is as a developer. We're like the NFL head coach down on the sidelines, responsible for all the players and all of the personnel. In a development project, it'd be the architects, the engineers, the contractor, the banker, the land seller, the title company, the surveyor, et cetera. That's our team we've put together, and we're reporting to the owner who's sitting up in the box in the nice weather. Most of our work is within the Portland metro area, which has 27 jurisdictions.
Okay.
If you count the cities and the counties. And then we do work up and down I-5, up as far north as Seattle, as far south down into California, and we did a couple projects in Phoenix. There's so many jurisdictions, and at each given project, there's generally a lead jurisdiction, where that might be a city or a county. But then there's a lot of other jurisdictions. There's the sewer agency, the water department or district, the stormwater, sometimes regulated by a different agency. There's the environmental quality department, the fire department, and so we can, on any given project, we can have easily a dozen jurisdictions, and sometimes they communicate well together, but other times they have friction between them, and we're in a position where we've got to try to make peace in order to get our permits.
So given you work with so many different parties, be it the architects, engineers, contractors, manufacturers, the like, and then multiple jurisdictions and multiple departments within each of these jurisdictions.
Yeah.
What are some of the biggest challenges that you see in getting a building built? You can treat it soup to nuts anywhere in that path.
Supply chain can sometimes be a real challenge in that materials don't arrive when they're supposed to arrive. And so construction can be held up, or fit up can be held up because of supply chain issues. So that's something we start managing very early in the process. The irony is that, for instance, electrical gear for larger manufacturing buildings, we have to order that sometimes 75 months ahead of time. And so we're actually ordering the electrical gear before we've advanced design past just a sketch, because otherwise we can't get it there in time when the building's done and ready for the power to be turned on. And then we have challenges with the jurisdictions because there's an inspection regimen, and there's a whole list of inspections that have to be done at different intervals in order to advance the project. And the jurisdictions won't allow you to take the next step until you passed inspection on the preceding step. And what happens sometimes, where Ichi comes in handy for us, is the inspector who's out in the field will write us up for an infraction or not pass inspection, citing some code. And sometimes that code's not right. Their citation of it's not right. And so then we've got to mount an argument to convince them that they've misinterpreted the code. Or in some cases, we had a situation where the inspector insisted there needed to be emergency egress lighting at every row of the racking in this warehouse. Our interpretation of the code is it was only required on the code exit path that the architect had determined that meets the exiting code provision of the building code. This plan checker did not agree with that, and she thinks that they should be in every row. We assessed that it was going to cost us $22,000 to install the emergency battery backup on all those lights, and we got together with the contractor and we said, we're probably better off to pay that $22,000 and just put those lights in that she wants, rather than fight, because it would probably take us weeks of an appeal to fight, and we might lose and have to do it anyway. And so we've got a tenant we wanted to move in that's paying $180,000 a month in rent. And so I don't want to delay them moving in. And then if we go towards the front end of the project, the initial design often takes us 3 or 4 months for these projects with a team of the architect, the planner, civil engineer, structural engineer, mechanical engineer, soils engineer, all contributing. And then we hand in this bundle of drawings. And then often we wait for months, literally, for the plan check to happen. If it goes smoothly, for it to take 6 months. If it doesn't go smoothly, it can take 12, 15, 18 months. And what's most frustrating to our customers is all that time that, from their perspective, nothing's happened.
That's really interesting to hear. And I'm curious, like going just back to that example with the emergency exit signs, there was the fee that you talked about. But I think from what we're talking about before, it actually took like weeks of emails back and forth with different people to even be able to resolve this issue, and having architect and engineer and manufacturer and everybody weigh into that. Is that typical that it requires just even that much time to solve some of these even very specific
it does.
code issues?
It's very rare that it's one design professional or it's only one person at the jurisdiction. In this case, for instance, the racking design firm was involved. The electrical engineer was involved because it's lights. And then at the jurisdiction, the electrical inspector was involved, the building inspector, and the fire marshal. And so what happens is one of them flags an issue, and then we try to respond to that, but then it's got to be approved by the others. And often what we'll do is approach them by email, or if we can occasionally get them to answer the phone, we'll trial our solution, and then based on their feedback, then have the design team alter the drawings, and that may take a week, and the client has to approve those, and sometimes we have to get it priced by the contractor before the owner will commit to it, and then we turn it in and wait.
Yeah. When it comes to the code compliance across all these different people and their own understanding, not even the jurisdiction, but just the different, on the commercial side, the engineers, the architects, contractors, and the like, how knowledgeable are they on these situations, or how much are people just like learning as they go? And if so, how do you guys learn? Is it usually just through pain and mistakes, or is there ways of getting in front of it?
Well, it's an interesting question. I feel like there's kind of 3 overlapping situations that lead to complexity here. One is that a lot of the more trained or well-trained design professionals are retiring, and the younger architects, engineers, planners that are coming into the profession, many of them, by their nature, just don't have the same expertise or experience, and they're hard to recruit. It's a universal truth that almost every engineering firm can't hire enough engineers. Civil engineers, structural engineers, mechanical engineers, they just can't find them. They're just not there. The schools are not, turning out as many as the industry needs. And so that's one layer. Then another layer is the codes are incredibly complex, and they're getting more so all the time. And that requires a deeper, broader knowledge base by the design professionals to address them. The third layer on top of that is our business, our customers, and what they're doing is getting more complex. As our world is, our microprocessors get smaller and smaller for water to wash the semiconductors. Was enormously complex, and it had a lot of flammable fluids that need to be mixed together in order to wash these semiconductors. And so the complexity of dealing with this. Another was, I asked Ichi about one client's issue about whether aluminum dust from milling aluminum was explosive. I didn't know about aluminum, but I asked Ichi, and sure enough, I got a response within seconds that yes, aluminum dust can be explosive given the right concentration of air and the dust. Well, that's something, of course, the design team wouldn't know anything about. And I was able to introduce that into the conversation early so that we would then begin to address it with the jurisdiction. So in summary, the industry personnel being younger and not having experience, layered with the complex codes and then the complex buildings that we're developing, it makes it really hard to get through that process of permitting fast.
If you could imagine a world where instead of an unknown 6 to 18 months to get a plan review complete, or an unforeseen inspector coming onto the job on late breaking that's going to find some violation that nobody had mentioned before, if that suddenly became predictable and something had happened in, instead of 9 months, in 3 months or a month or less, how would that impact, you think, the speed and overall cost of the construction?
It would be very beneficial. These projects, generally speaking, we tell a customer it's going to take at least 2 years to deliver it from that first time we sit down with them to do the design, the permitting, and the construction. And many of them say, we just don't have that time. If they aren't able to take that on within a certain period of time, they're going to miss out on that new business opportunity. And so speeding up that permitting process would increase our economy. If you think about it, multiplied by lots of projects, and in the residential sector, it would go a long ways towards addressing the housing shortage. A large apartment complex will bring more housing units to the market faster, in one project than a whole bunch of single-family homes. But the complexity of the codes for that make it a long permitting process, and so the developer can be reluctant to do that because now maybe the rents are sufficient that they can get a return on their investment, but who knows about 2 years from now? If it's going to take a year to get the thing drawn and permitted, another year to build it. And so their risk goes up a lot as time goes on. And so that shrinking that permitting process would have a dramatic impact, favorable impact on the industry.
How are you seeing AI change your work or your team's work or all the different constituents that you worked with day to day?
We're seeing AI implemented in the writing part of permit applications. The planners write often 50, 100-page documents that respond to every sentence of the planning code with how our project conforms. And they're using AI to help in that writing so that it's concise and it's crisp, it's readable for the jurisdiction. We're also seeing it to some extent in the interpretation of plans and solving riddles with the code. And that's where Ichi has just been really, really helpful for us. And we can troubleshoot things and move them along faster. You alluded earlier about all the different people who are involved. It might be 3 plans reviewers and a couple of the design professionals. If we can, using AI, understand what the solution is faster, then we can get that through the whole team much faster.
Things we've heard almost universally from people is this desire to have the same rules of the game no matter who's playing it, that the jurisdiction and everybody there and the developer and all the people working for that project all understand and know the codes in the same way. So if you could imagine a world where that happens, how do you imagine that's going to impact and change the projects?
It'd be really good. Where I think that would help the most is where codes overlap or intersect one another. And a good example is the building code and the fire code. And those generally are reviewed by different reviewers, often different agencies, sitting in different buildings or even different cities. But those rule books intersect at where are the exiting aisles that have the exit sign that the fire marshal wants to see. And the fire code says something about it, and the building code says something about them. And the architect is getting proficient at the building code, but maybe not as familiar with the fire code. An AI product could help the design professionals to understand how to solve to both codes in a really quick time frame, as opposed to they draw it up the way it conforms to the building code, turn it in for review, and then the fire marshal marks it up, sends it back, and they scratch their head. Well, what are we supposed to do? The building code says this, the fire marshal says that.
Gotcha. So it's like literally can be like months of delay of those iterations.
Yeah.
Well, one of the things I'd love for you to speak to a bit is you use Ichi and AI in a mobile capacity, like on the go. And so if you could just help us understand a little bit of like a day in the life, job to job, and how you're able to use AI and what kind of time it saves you or other kind of help it saves you of being this companion with you on the ride.
Yeah, we have generally weekly job site meetings, and the design team and the contractor and the owner will meet and go through generally a fairly regimented agenda about issues that have come up since the last meeting. And coming out of those meetings, it's not unusual to have something that's puzzling us. A week ago, the contractor pointed out that the drawings were inconsistent on where the foundation drain would go next to the concrete foundations. And then the question arose, well, what does the slope have to be on those foundation drains? And if the slope isn't too steep, then we can probably make it all the way down to the end of the building and run into the storm sewer. So as I was leaving the job site, I dictated to Ichi to pose the question, what is the minimum slope required for a foundation drain in Millersburg, Oregon? And then when I got back to the office, I opened my laptop and here's the response. And it cites the section of the plumbing code that applies and the section of the mechanical code that applies. And it turns out 0 is the minimum. It can be flat. Well, I was able to email that then to the civil engineer. He says, well, this is going to be easy then. And so we were able to get to that solution so that the next day the contractor is actually installing that drain. It didn't have to delay.
When it comes to tools like Ichi that are purpose-built for this industry, why is being built specific for this industry important to be able to trust it?
To the extent we've used ChatGPT or Gemini as examples to try to answer these code questions, we don't get the same level of detail, and it's not always right. One of the things I really like about a more recent edition of Ichi is where the code section is underlined and we can hover over that and see the actual code and read it. And so here's the interpretation by Ichi, but then we can read the code itself that we know that the plans examiner is going to look at and see the answer right there.
And 5 years or 10 years from now, as Ichi and AI gets more and more advanced and powerful, how do you imagine it's going to impact the industry and the people that you work with?
I think one of the things it's going to do is bring some design professionals, applicants like ourselves, and the jurisdiction plan reviewers closer together. There's less of, gosh, I need to dig through that code and really understand it, and I don't have the time to do it. So that delays a decision, which then gets angst because we've got contractors standing around dependent upon a solution. So I think that speed of AI to the solution that everybody can rally around, I think is going to bring everybody together, because then there's just less friction. It's just like, oh, okay, yeah, that's the right answer. That's the right answer. And they check the box and issue our permit.
Yeah. One thing I wanted to ask you about is you've got 30, 40 years of experience in this industry. And I think sometimes there's maybe more like animosity from more tenured generation, or AI is something more for folks that are just like coming up, but it's something you've been able to adopt and have other people on your team adopt. What would you say to the person that's a little bit more skeptical of, can I actually use this and will it provide value?
Just try it. You'll like it.